All right, in this lesson, we are talking about applications of exponential functions. And the most common applications of exponential functions is when something is growing or decaying by a percentage. And so our exponential growth formula looks like this. You may have seen this in Algebra 1, where A is your future amount, P is your present amount. You could also say value instead of amount. R is your growth rate. And it's given as a percentage. And so in parentheses, I'm going to say percent to decimal because you'll want to use the decimal form. And then T is the time. And because R is usually an annual rate, you want to make sure your time is years. Okay, so looking at these first examples, it says the amount of $500 is deposited into an account that pays 9.5% interest compounded yearly. What is the balance after 3 years? Okay, and so our current amount is 500. The interest rate is 9.5%, and so it is growing by 9.5%. We want to move the decimal 2 places to get the decimal form. So our R value is 0.095. And then after 3 years, that's our T value. And so we're trying to find the future amount. And so using our formula, A equals P, 1 plus R to the T power. So A would be 500 times 1 plus 0.095 raised to the 3rd power. Okay, and so we can get our calculator and type that in just as is. 500, 1 plus 0.095 raised to the 3rd power. We would get $656.47. For money, you keep 2 decimal places. And so for your final answer, just add your $sign and highlight. Okay, this next example says, how much would you deposit an account that pays 6.5% interest compounded annually to have a balance of 5,000 in 15 years. So this time our future amount is 5,000. That's our A, not P. And then R is 0.065. And then T is 15 years. So when we set this up, getting our formula, A equals 1 plus R to the T power. And so we know A is 500. We don't know P. That's what we're looking for. 1 plus R to the 15th power. Okay, and so what we want to do to solve for P is we want to divide by this 1.065 raised to the 15th power. We want that to isolate the P, and that P is being multiplied by that expression. So all we have to do is divide by that expression. So I always do all of the algebra before I actually go to my calculator so I don't get a bunch of rounding errors. And so I'm leaving it just like that. You could even leave that as 1 plus 0.065. That's just an easy computation to do. And so in your calculator, alpha y equals will give you a fraction bar, and then 500 over 1.065 raised to the 15th. Okay, and so that gives us $194.41. Okay, and always check and see if your answer makes sense. If you got like a negative answer or a value that's higher than the 5,000 we're trying to get to, that would be a sign you did something wrong. Okay, 10 years ago, Mr. and Mrs. Boyce bought a house for $496,000. Their home is now worth $550,000. Assuming a steady rate of growth, what is the annual rate of appreciation? Appreciation means growth. Depreciation means decay. Okay, and so looking at what we're given, we see T is 10. 10 years have passed, and the present value at that time was $496,000. And then the future value is $550,000, since we are in the future. And so we don't know R this time. Okay, and so let's write down our formula. Fill in what we know. We know A is 550,000. We know P is 496,000. We don't know R, but we know T is 10. Okay, and so this time we're trying to solve for R. And so we do need to isolate that set of parentheses. And so the first thing we have to do is divide by the 496,000. Okay, and so to simplify this a little bit, we can cancel some of these zeros just to make it look like a nicer fraction to type in. We could even simplify that fraction more, but again, I don't want any rounding errors. So I'm going to leave it just like that for now. Okay, next, keeping in mind we're trying to get R, we have to get rid of this power of 10. And so the way we do that, which you may remember from our radicals unit, is we can raise this to a 1/10 power. Raise that to a 1/10 power. And so now my 1 plus R is free. And it equals the 550 over 496 raised to the 1/10 power. Okay, still not going to the calculator yet, because again, we're trying to solve for this R, so we have to subtract 1. Okay, and so now we are ready for the calculator. We're going to need some parentheses. We're going to need to be very careful when we type this in. Okay, and so start by getting your parenthesis, get your fraction bar, and then type 550 over 496. Close the parenthesis, raised to the 1/10 power, get out of the exponent, and then subtract 1. Okay, and so that says 0.010, and then 38 would round to 4. We want the percent form. Remember, R is always given in decimal form, so to get the percent, we move the decimal 2 places to the right. If you want, you could even type times 100, just to see what that decimal would look like. And so 1.04%. And if they specify what to round to, just pay attention to that. Okay, 1.04%. All right, last example, the city of Knoxville, Tennessee grew from a population of 546,488 in 1980 to a population of 585,960 in 1991. Okay, assuming a steady rate of growth, what is the annual rate of appreciation? So once again, we're looking for that R value. Okay, so let's write down what we know. The present value was 546,488. The future value is 585,960. And then our T, we're going from 1980 to 1991. That's 11 years. So our T is 11, and we still don't know R. Okay, so when we set this up, I like to write the formula down each time and then fill in our information. We have 585,960, and then 546,488, 1 plus r to the 11th power. Again, we're solving for r, and so we need to isolate it. And so our first step, divide. And then I'm gonna go ahead and write that down. I don't like rounding errors, so I only go to the calculator one time. Otherwise, you're gonna be just writing a bunch of decimals, which isn't helpful. And then we are going to raise both sides to the 1/11th power to get rid of that 11. And so we have 1 plus r equals that huge fraction. Raise to the 1/11th, and then we are going to subtract 1 from both sides. And then we can type that in our calculator. Parenthesis, fraction bar, 585, 960. 546, 488, raised to the 1/11th, minus 1. Okay. Says R is 0.00636, and then we are going to move our decimal. So that is a 0.63, and we'll round that to 4%. It's a very small percentage, which is more accurate for bank accounts. They're very, very small percentages. All right, in these last two examples, we are actually doing decay. And so it's the same formula, only instead of adding to 1, we are subtracting from 1. And that 1 represents 100%. Okay, and so when you are growing by a percentage, you want to add that percentage to the original 100%. That's how it's going to grow. And then if you are losing a percentage, that's when you subtract that percentage from 100%. And so that kind of helps make the formula make a little more sense. So you just won the lottery and decided to buy your mom a brand new Range Rover Sport, which costs you $62,600. Sadly, the value of this car depreciates at a rate of 25% per year. How much will her Range Rover be worth after 5 years? Okay, so getting our information, our present value, our depreciation rate, and then our time. Okay, and so we know the present value is $62,600. We know the rate of depreciation is 25. Move your decimal 2 places. And then we're looking for 5 years, and we're trying to find that future amount. Okay, so 1 minus r because of that word depreciation. If you see that on a test, that's going to be your cue to use the minus. And so A is unknown. P is 62,600. 1 minus 0.25 raised to the 5th. If you want to simplify those parentheses, you would see 0.75. And so that shows we're just keeping 75% of the value each year. So it's going to depreciate, and we would just keep multiplying by 0.75 for 5 years. Okay, and so 62,600, 0.75 raised to the 5th. And so $14,855.27 is how much that car will be worth in 5 years. Down from $62,000. That's a lot. All right, in 1980, there were 1.2 million elephants living in Africa. Because the natural grazing lands for the elephant are disappearing due to increased population and cultivation of the land, the number of elephants has decreased by 6.8% per year. In what year did the population fall below 50,000? All right. And so this time we know that our starting amount is 1.2 million, and 1.2 million is 1.2 times 10 to the 6, which means you need to move the decimal 6 places to the left. And so 1, 2, 3, 4, 5, 6. Okay, and so that way when you're using your calculator, you can either type in 1.2 times 10 to the 6, or you can write all the 5 zeros after the 1, 2. Okay, and then our depreciation rate is 6.8, which is 0.068. And then we don't know the time this is where things get a little more challenging. But we know the future amount is 50,000. Okay, and so what we're going to do is set up our formula. We know it's depreciation, so we're using the minus. And then we know our A value is 50,000. We know the P value is 1, 2 with 5 zeros. And then 1 minus 0.068 raised to the t. All right, so this time we are solving for the exponent. That screams that we're going to need log. But let's simplify things as much as possible. Let's divide by the 1 to 1.2 million. Oops, that's too much. Okay, and so that gives us 5 over 120, which we could simplify even nicer than that, but I'll leave it. And then 1 minus 0.068, we can clean that up. Is 0.932 raised to the t. Now, the reason why I wanted to clean this up as much as possible is because now we're looking for the exponent. And so once you have an exponential expression equal to a number, that's when you're ready to convert to log. Okay, and so our base here is 0.93, log base 0.93 of 5 over 120 equals t. So log base 0.932 of 5 over 120 equals the t. Okay, and so to type this in, that's math alpha math. Okay, so in your calculator, math alpha math 0.932 5 over 120, and so we get 45.12 years, or 13 years. And so go back and see what question they're asking. They want to know in what year, okay? And so in 1980 is where we're starting. And so we have to add this to 1980. Okay, and so if you want, you can do that in your calculator. We really just need to add the 45 years plus 1980. So that's going to be year 2025. So it's already passed.